Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam LTAM, long-term actuarial models, a defined benefit plan provides for a retirement benefit of $500 per month for each year of service at the normal retirement age of 65. You are given the only decrement before retirement is death. Mortality follows the standard ultimate life table. Deaths are uniformly distributed over each year of age. On retirement before age 65, the benefit is adjusted such that the reduced benefit taken immediately on early retirement has the same actuarial present value as the accrued benefit deferred to age 65. Interest rate is 5%. A+65 upper 12 is 13.086. Calculate the percentage reduction factor that should be applied to the accrued benefit for an employee who chooses to take their pension at age 64 instead of age 65. And here's the solution. Let's denote the reduction factor by R. Let B be the unreduced annual benefit at age 65. We have, based on the prescribed actuarial equivalence of both methods of payment of benefit, 1 minus R times B, benefit at age 64, reduced from the benefit B at age 65, and the reduction factor is R, times A+64 upper 12 equals P64 divided by 1.05, so pure endowment factor for 1 year, times B A+65 upper 12. And this is the actuarial equivalence prescribed in the problem. This is the way they say the two benefits relate. There's one confusing part in this, because the problem says that the benefit is the number of years of service times 500 times 12, and that's the amount of the annual benefit. If the person retires at age 64, the person will have 1 year less of service. So shouldn't there be some accounting for that? And the answer is, well, actually the problem prescribes that this is the actuarial reduction. This is the way it works. And I'm sorry that it's confused. And if you wanted to add some additional reduction for the number of years served being 1 less, then there is a bit of a mystery to this, because then the question is that reduction for 1 year less served included in this factor R, or is it not? So I'll say that it really looks to me like they meant to say this is the way it is, that the entire reduction that is given for retirement at age 64 is represented in this factor R, whether it's because it's 1 year or anything else, because this is the entire reduction. Therefore, we will just disregard the issue that there's 1 year less of service at that point. Now we can divide both sides by B to simplify things and obtain R equals 1 minus Q64, because P64 is 1 minus Q64, and we can look it up in the table. There is no P64 in standard ultimate life table, but there is Q64, and we'll look it up. So 1 minus Q64 over 1.05 times A+65 upper 12 divided by A+64 upper 12. And we are given A+65 upper 12, that's 13.086, but we are not given a double dot 64 upper 12. Using the uniform distribution of deaths assumption and data from the standard ultimate life table, we can actually obtain it. We can write a double dot 64 upper 12 as alpha of 12 a double dot 64 minus beta of 12 because of uniform distribution of deaths assumption. So this is the formula for the case when you have UDD, uniform distribution of deaths. And from the table, we can actually look up the values of alpha of 12 and beta of 12. That's on the very last page of the table. And the interest rate, of course, is 5%, so everything is consistent with the table because the table uses 5%. Okay, so this is now 1.0002 times 13.8363 minus the 13.8363, by the way, is from the table as well, from standard ultimate life table, minus 0.46651, also from the table. And this becomes approximately 13.372553. Okay? Then R is equal to 1 minus Q64 over 1.05 times A double dot 65 upper 12 over A double dot 64 upper 12. And we look up Q64 in the table, and this becomes 1 minus 0.005288 over 1.05 times 13.086 over 13.3725573. That's approximately 0.072955566. And that's answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.